Welcome back to College Algebra. In this section, we're going to talk about two things, really. We're going to start off by talking about the library of functions, or sometimes called parent functions. This is meant to lead into the next section where we talk about transformations of functions. Transformations of functions are when you make a small change to the formula of a function and it will have an effect on the graph. It will either shift it up or down, reflect it, maybe bend it a little bit. But to get there, we really need to know what's just a bunch of basic functions. What are we going to see a lot of? And that's what this video is going to be about. So we're honestly not going to do that many examples. I'm just going to present a whole bunch of functions. And these are things you should be able to recognize either from their equations or their graphs. So here we go. Here's the list. Functions to be familiar with. Linear functions. The squaring function, the cubing function, square root, cube root, reciprocal, and absolute value. So let's look at these. What's a linear function? So what's a linear function? We talked about linear functions a lot. Their functions are going to be mx plus b. And what's their graph look like? Well, they're all just lines. If you have a line, its formula is something like this, mx plus b. And specifically, it's just some kind of manipulation of the prototypical linear function y equal x. Y equal x is just a diagonal function. It goes, up 1 over 1, up 1 over 1. Every other function is just some kind of manipulation of that, every other linear function. How about the squaring function? So f of x equal x squared. We'll talk about some other properties of these once we get a few of them on. So let's see here, squaring function. Let's see here. It starts at 0, 0, 1, 2, 4. I could put a 3, 9 as well, but I think I'll leave it there. This has the neat property of it is symmetric about the y-axis, so it is an even function. So once you get one side of it, it's pretty easy to graph the other side. The cubing function, I'm going to need, let's see, I'll put that here. Yep. And I don't actually need that much horizontal space for this because the cubes go up and down very quickly. So 0, 0, we graph f of x equal x cubed. We got 0, 0, 1, 1, because 1 cubed is 1. 2 cubed, though, is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Negative 1 cubed is negative 1. Negative 2 cubed is negative 8, which I believe is right here. 1, 2, 3, 4, 5, 7, 8. Alright. So this goes down like... Oh, that's too steep. My hand is just wanting to curve too much. That's steeper than that, Paula. There we go. Nope. I'm going to have to get used to drawing on this tablet. It's still pretty awkward for me. But I imagine I'll get better. We can all hope. There we go. X cubed. So some things about these. You can tell, first off, domains. This is negative infinity to positive infinity. Negative infinity to positive infinity. Negative infinity to positive infinity. Range. Well, that varies a bit. Range. Well, this one goes from negative infinity to positive infinity. And this one does. This one does not, though. This one's range goes from 0 up to infinity. And there's some other things about them. You can think about this as an always increasing function, the way I've written it. Although certainly lines can be always decreasing or constant if they're going straight across. Also, this one is always increasing. If you look at negative x cubed, which we will when we get to transformations of functions, that would be this function. Basically the same thing, just flipped top to bottom, and that would be always decreasing. So this is always increasing. So yeah, that's the first three. Let's keep going. So let's talk about the square root function. So f of x equal the square root of x. Let's see here. Don't need that much vertical space. Do need some horizontal space. So let's see, 0, 0, 1, 1. 4, 2, and let's see, what's the next perfect square? Because I got a square root, I kind of need a perfect square. 9. 9, of course 9. 9 square rooted is 3, so I believe 9 is right here. There's 10 of these, and yeah, there's 10 tick marks between the thick lines, so be right here. All right then. Oh, that's much better. I'm getting the hang of it. All right. So square root x looks like that. Notice it has a lot of interesting properties. Its domain starts here, so its domain is 0 to infinity. Also, its range, though, because it also starts at y equals 0 and goes up infinitely. It goes up much more slowly than it goes to the right, but it does go up infinitely. It's another always increasing function. But this is really the first one we've had that has a limited domain. It doesn't go infinitely to the left, because if you plug in, say, -4, square root of -4, well, that's 2i. Remember, square root of a negative is imaginary. So because of that, domain doesn't exist over there. Let's look at the cube root function. So f of x equal the cube root of x, or alternatively, remember, from the end of chapter R, that's also x to the 1/3. Let's see here. Don't need that much vertical space on this one. Do need horizontal space, though. All right. So, this would go from, if I plug in 0, cube root of 0 is 0, 1 is another easy one. Cube root of 1 is 1. Next perfect cube, 2 cubed is 8. So yeah, is doing 8. So 8 cube rooted is 2. So yeah, we'd have this point table. 0, 0, 1, 8, 2. And we'd have similar for negatives, because -1 cube rooted is -1, -8 cube rooted is -2. So I'll put those points in as well. Right here, I think. Yeah. So this... I'm realizing how I have to hold my arm if I'm going to draw a relatively smooth line. Okay. Domain and range of this is, well, it goes infinitely to the left, infinitely to the right, so -infinity to infinity for the domain. Its range, well, it goes infinitely down, infinitely up. So its range is -infinity to infinity. So there we go. Always increasing, always increasing. A lot like the cubing function in that respect. They are related. They're actually inverses of each other. We'll look at inverse functions much later in the semester. But yeah, moving on. What do we got left? We got the reciprocal function. So that is f of x equal 1 over x. Let's do... That's probably enough. So let's make ourselves a point table for this. It's easier than you might think. Can you plug in 0? Well, if you plug in 0, it is undefined. So no, there is no point at 0. But I can plug in 1. Plug in 1, you get 1 over 1. That's easy. 1. Plug in 2, 1 half. Plug in 3, 1/3. How about if I get closer to 0? Well, what do you get if you do 1 half? Well, remember, 1 divided by 1 half, that is just a division of fractions. It's 1 divided by 1 half. A lot of people have trouble recognizing that this means the same thing as this, but it certainly does. And almost everybody learns mechanically, you just flip this and multiply. 1 times 2. So with that in mind, the multiplication by 1 doesn't do anything. So the only thing that happened was the flipping. So it'll just flip the fraction. So that'll get me 2, and like if I did 1/4, that would get me 4. So that'll be plenty. If I plug in 1, I get 1. I plug in 2, I get 1 half. Plug in 3, I get 1/3. So it's actually getting tinier and tinier as I go to the right. It's approaching 0, but it's never actually crossing it. It has what's called a horizontal asymptote, because it gets closer and closer to the x-axis, but it does never cross. And it actually does the same thing with the y-axis, because if you look here, you do 1 half, you plug in 2, 1/4, so half the distance again, you get 4. And like if you did 1/100th, it would be up at 100. Well, it's going up infinitely, but it's never actually crossing the y-axis, because as we said, there is no point on the y-axis. 0 is undefined. So, infinitely up. Let's look at the other side. If we plug in -1, well, it's very similar. 1 over -1 is -1. 1 over -2 is -1 half. -3 is -1/3. So this side is doing this number. Having trouble again. And as you approach the center from the left side, -1 half, -2, some more. Does the same thing. Goes infinitely down, doesn't cross. So that's the reciprocal function. Its domain. Well, it goes infinitely to the left, but doesn't include a point at 0. Infinitely to the right as well. So this would be everything but 0. This would be the interval notation, which is what our homework system asks for a lot. The set builder's notation is actually easier in this case. It's usually easier when you just have to take out a finite number of points. Not equal 0. Range would actually be the same thing, because it includes everything but the actual x-axis. Y equals 0, so it would actually be that as well. Just y values instead of x values. And lastly, we have the absolute value function, which I think we can fit in here. It's a pretty simple function. Absolute value of x. This is actually the first piecewise function we looked at as well, although we're not defining it as such right now. It's pretty easy to graph. You don't really need much negative space. So 0, 0, absolute value of 1 is 1, absolute value of 2 is 2. So it goes up like y equal x to the right. And to the left, well, -1, absolute value is 1. -2, absolute value is 2. This is going up this way. Yep, come on. So yeah, There's absolute value. You can recognize it by its sharp point. So all you're going to be doing in this beginning of this section is just recognizing these functions, dealing with them. So in these problems, we're matching the graph to its function. So we look here, 11. Well, that is the squaring function. So we find it here, C. Now try and max all the rest of these just yourself for a second. You tried yourself? We'll finish it here. 12 would be a constant function, just a flat line, A. This is square root. Square root. This, absolute value, is the one we just looked at. This, well, that's a linear function. Specifically, it's the diagonal function, it looks like, so that would be the identity function. This is definitely the cubing function, so the cube. This, by the way, would be the cube root, so that would be h. And then this is the reciprocal function. So there we go. That'll be it for this video. Next video, we'll talk about piecewise defined functions. That's a little bit more complex in theory, but once you get the basics down, it's not that hard to deal with. See you in that video.